Hi class, welcome to an example problem for unit 6.3 and 6.4. I'm sort of combining them because they are pretty similar. In unit 6.3 and 6.4, we learn about frames and machines, respectively. So I've chosen problem 6-97 from the 13th edition of the book. And the picture the book gives looks something like this, where we have this machine, this guy's pulling on it, and he's pulling up some weight that's attached to the end. And the big difference between frames and machines and trusses is that with frames and machines, we are usually dealing with members that are 2 and 3 force members. With trusses, everything was a 2 force member. And so there were only forces, axial to those beams. But with these guys, we have now 3 force members. And so there's a little bit more to it. We aren't really going to be solving for joints anymore. We're going to be solving for beams, and all the forces acting on individual members or beams, whatever you want to call them. So in this problem, I've gone ahead and redrawn this here. So again, there's a person who's pulling on this handle, and there's some weight represented by force F here at the end. And what we're asked to find is the force F for equilibrium. So with this sort of a problem, the way I normally think about them is I'm going to basically end up with free body diagrams for some number of my individual members. So in this case, I am going to start with a free body diagram of this little Nike swoosh looking guy on top. And so I'm going to go ahead and redraw this as a free body diagram. And so I got this 6-pound force here. And then at this joint, I have a force some of these. Joint A, this is joint B, this is joint C, this is joint B. The force A, Y, force A, X, and then BD, this is a 2 force number, so there's only going to be a vertical part to that. And then let's put some of these dimensions back in. So let's do that. That's 4 inches. This distance here is 4 inches. And then the overall height here is 25 inches. So now, let's see. I have 3 unknowns on this free body diagram. And I have 3 equations, sum of forces in x, y, and z. Sorry, sum of forces in x, y, and the sum of moments. So I should be able to solve for all of these unknowns without too much trouble. So I'm going to start with the x because these other 2 are purely in the y. So I'm going to say the sum of my forces in x equals 0, and the f of x plus 6, and pretty clearly f of x must be -6. So that's not a final answer, but I am going to use that later. So on my moments about A now. So I'm going to do some of the moments about this point A so that I can solve FBC. Right? If I just do the Y, some forces in Y, then these are both. So I'm going to isolate one of them. So some of the moments about A is going to be 0. And that ends up being -6 times 25. That's going to be that's negative moments, -6 times 25. And then FB is also going to be negative with the way I've drawn it, so it's at a distance of 4. So negative FBC times 4. And I do some math, and I get that FBC must be negative 37.5. So what's that tell me? That tells me that this joint is actually in compression. save that for later. Now I'm going to look at some of my forces in y. That'll be 0, and what I end up with is F AY plus F BC, and I can sub into.
Okay, I found this on the web for 1972.
What?
Check it out.
Interesting. And then I can solve, and I get that FAY equals, or FAY 0 equals FAY minus, oh, sorry, I should, FBC is going down, so plus 37.5, and FAY equals negative 37.5. Okay, so I've solved those forces here. And now ultimately I need to get to the free body diagram for this guy. And so let's draw him. That free body diagram looks sort of like this. Yeah, force F here. I have FAX. F T X. All right. So this is kind of what this free body diagram would look like. So you'll notice, so this is still joint A, right? This is pin A. And I've drawn FAY and FAX going into it, just like I drew going into it over here. Now the directions are flipped. And that, it's sort of similar to why, you know, if I had a truss, you know, just like with the trusses, we always draw if I had a force that was acting at, you know, on either end of a, how to explain it? You can almost think of like the pin that connects these as a, you know, a little mini 2-force member. And that's, you know, so it's putting in you sort of the equal and opposite force into the joint. So it's going right, FAX is going right, and FAY is going up over here, and over here FAY is going down, FAX is going to the left. So they're sort of equal and opposite. And if you just kind of keep that convention, then you can just use the same values. It's pretty similar to what we were doing with the trusses, how we just always drew them going, you know, in tension or whatever. But if you have questions on why I did it that way, why I do it this way, feel free to ask. So we got this. We've already solved for FAY and FAX. FAY is, you know, negative 37.5. FAX is negative 6. We don't know FDY. We don't know FDX. But ultimately, we don't actually need to know these. We just need to know F. So if we're smart about this, we can say, hey, all I need to know is F. If I just take the moment about D, then I cut out FDX and FDY entirely. And then I'm just left with these guys, which I do know, and F, which I don't. And I can solve it with minimal amount of work. So I'm going to go for the sum of the moments about D equals 0. And that ends up getting me. So FAX is going to be positive. So I get FAX times 5. FAY is also going to be positive if we've drawn it. FAY times 9. And then F, it's also going to cause a positive moment by the right-hand rule. So I get F times 39. So we're going to 7, 1, 3, 0 equals negative 6 times 5 plus negative 37.5 times 9 plus F times 39. So I can do a bunch of math. Negative 30, negative 337.5. And I wind up with F equals 9.42 pounds. That is my answer. So again, with these frames and machine problems, similar to trusses, except now we're dealing with 3 force members. And we basically are making, instead of free body diagrams about joints, we're now using free body diagrams of the members themselves. And you just sort of work your way across and recognize that forces transmit along the pins. And so we know that, they're shared between these members, and you can just sort of work your way across using the same principles we've learned before and solve for whatever you're being asked to solve. So as always, if you have more questions, don't feel like you quite understand this, feel free to reach out and message me, meet up with me in my office hours. I'm always happy to help. So good luck.